start with the dependent motion. So guys, what about dependent motion? What do you think? What about dependent motion? Dependent motion means that one motion depends upon another, right? So if I know the motion of A and B depends on A, I can know the motion of B as well as the acceleration of B. Now, what is the trick? What is the trick to solve such problems? The problems of dependent motion. What do you think, guys? It is about what? How can I solve dependent motion problems?
CD.
Okay, so guys, it is about relating the positions, and this is because the rope or the cord has a constant length. Yes, Michelle. So, but guys, since this rope has a constant length, if there is a deformation, right? So you're gonna see in strengths of materials that in fact the rope has a certain deformation under a certain force, right? And this could lead after all to a plastic deformation. But in our case here, we are considering that this rope has a constant length, and this means that this rope will not increase its length under a force, all right? So there is no deformation of the length of this rope, okay? So knowing this fact, I'm gonna relate the position in order to find all other variables, okay? So since I know that, for example, SA plus SB is equal to a constant length, I can do the derivation to find V and then to find A. Let's start by this problem. I'm also, guys, gonna do only 2 problems, and you're gonna solve the third one. So if the end of the cable at A is pulled down with a speed of 5 meters per second. So guys, I know the speed at A, and I need to determine the speed at which block B rises, right? So what will be the first step? What is the first step, guys? What is the first step in dependent motion? It's to indicate what? Assign the reference, or it's called the datum, right? So I'm gonna assign the datum at this point, which is the center of pulley, right? So this will be my datum. And then what I'm gonna do is to assign this as S what? SA, all right? So this will be SA. Okay, so I know that VA is 5 meters per second, and as a matter of fact, this VA is positive or negative? Guys, this VA is positive or negative? No answer? Ihab is saying is negative, as well as Michelle. Why is it negative? Nader, why is it negative? It's not. Yes. Guys, I assigned the direction of SA. Okay, so what do you think, guys? What is the sign of VA? Is it positive or negative? So I'm gonna repeat, guys. I assigned the datum here, and then you have always, guys, to put SA from the datum to the point, right? Which means this is SA. This is the positive direction of SA. Now, what about VA? It is positive or negative? It's positive, guys. It's not negative, okay? So pay attention, guys. The datum is from this point, and then SA will be from this datum to the point. Now, if you take your datum down, so let's say you took the datum here at this level, then yes, SA will be upward, and then in this case, VA will be negative. All right? But usually, guys, we take the datum in the upward direction, or we take the datum at the highest point, and then SA will be downward, and then VA will be positive if it is downward. So VA is positive, okay? Now, what do you think, guys? What about the second point here, which is SB? It's from this datum to this point, right? So I'm gonna also increase the weight so you can see it. I think now it's clear, right? Now this is SB. Guys, this length here is constant, right? So it's constant. So I can remove it from this SB because it's always constant, right? So I can remove it from this SB, and then I can assume that SB will be to this point. All right, guys? You agree with me? Because this here, this length here is always constant. So the length here between this point and this point is always constant. And this means that I can say that this is SB. Or you can extend this SB to the point B. And then, guys, put on your mind that this dimension here is constant. So as you want. So this is SB. Okay. This is the first step in dependent motion. Now, what is the second step? So I assigned my datum, I put SA and SP. Now, the second step is to find, no, it's to find the constant lengths. Right? Because in fact, guys, you can face some problems where you have more than one rope, right? Now here, I only have one rope, which is from this point down to this point, to this point, and then to this point, right? So the whole up here is the same, right? So L is constant. Okay, now what is L? L in fact is SA plus, I'm gonna call this L1, which is constant, plus L1, plus, what is this length from this point to this point, which is the rope length here? What is this length, guys? From this point to this point. It is SB minus a certain constant that I'm gonna call L2. All right? So this is L2, guys, all right? It's constant. When you practice, guys, the problems of dependent motion, you're gonna directly write SA plus SP without minus L2, right? Because you're gonna know that this length will vanish whenever I do the derivative. All right, so this is L2. Okay, so this length here is SB minus L2. Okay, am I done? Plus what? Plus this L3 here. So the rope length has also L3. All right, and then what about this length here from this point to this point? It's also what? It's also SB minus a certain constant here that I'm gonna call L4. Right? So guys, this SB from this datum to this point minus this L4, which is constant, will give me this length, all right? So it is also SB minus L4. Now what about, okay, plus this length here that I'm gonna call L5. So this L5 is this arc right here. And plus the last one is the length between this point and this point, which is also what? Which is also what, guys? Which is also SB minus L3 minus L4. Or it's not, oh, sorry, L4, just 1 minute. I mean this one. This length was what? Is it called L3? So I'm gonna repeat. This is SA plus L1 plus SB minus L2. No, L3 is this arc. L3 plus SB minus L4, so it's minus L4, which is this one, minus L6, and L6 would be the length between this one and this one. All right, so they are all constant. You can write minus constant, okay? So you can write only minus constant 1, minus constant 2, minus constant 3. So how many SB do I have in this equation? It's this SB, and this SB here, right? So I have 3 SB, and this would be equal to L, total L. And this means, guys, that SA plus 3 SB is equal to constant. Which is also mean that VB is equal to minus VA over 3. And it should be, guys, in the opposite direction, because if I push A downward, B will be lifted, all right? So VA is here 5, so VB would be minus 5 over 3 meters per second. All right, guys, do you have any question?
Yes, doctor. I have a question, please.
Go ahead.
بس بالنسبة ل SB, how did we know إنه كيف we should take it?
Okay, so this is the first problem solved in dependent motion. So you're gonna find that it's somehow complicated, but then if you practice, go to the textbook and practice, all right, from the examples to the problems, all right? What you should put in your mind that each rope has a certain constant length, all right? So this rope has a constant length, and I need to express this rope in terms of the position. Okay, position of what? Of my variable points. Now I know here that my variable points are A and B. If I push A downward, B will be lifted upward from my experience, all right? Now how to explain this in the equation? I'm gonna set the datum and then set SA, all right? And then I'm gonna find the lengths, okay? The lengths of the rope. But I know that this is SA. And I know that this is constant. So I am now at SA plus a constant, all right? Plus SB, okay? You can take SB until this point because you are sure that this is constant, or because this doesn't belong also to your lengths, right? So SA plus this certain constant plus SB plus a certain constant, which is this R, plus this distance here. Now this distance is also related to SB. This distance is also a variable that depends on SB. It's SB, in fact, this distance here is SB minus a constant, okay? So it's also SB, and then plus a certain constant, which is the arc here, plus also SB, because in fact, this distance from this point to this point is SB minus a certain constant, all right? So it's also SB. You can imagine this. If I push A down, then B will be lifted by how many ropes?
3 ropes.
3 ropes, and that's why you're gonna have a coefficient of 3, right?
That's
3
my question.
of the same rope. 3 of the same rope, right? Because if I have 2 different ropes, this will be different, okay?
Yes, can I directly say, doctor, إنه SA is equal?
No, you cannot. You
I
cannot.
should
You
show
have to put this in this in an equation, okay?
Yes, thank
And
you.
I advise you to do more practice. Okay. Now,